All right, we're looking today at topic 1-2. We're looking at day one of that topic right there, talking about measuring segments. And this first thing we're going to talk about is measuring segment length. All right, so we look at our paper right here, and we talk about length, okay? The length, you got to think about how long something is. Well, that's a measurement, right? It's measuring the distance between 2 points. So you can think about like the length of a yardstick is the distance between the two ends of that yardstick, right? And that's about 3 feet. So when we look at that, what we're going to do is when we're looking at points, we're looking at segments, we can put them onto a line. And particularly if they're on a number line, we can just subtract the values of those 2 points, okay? Because we're finding the difference in those two values, okay? After we do that subtraction, we're going to take the absolute value of the difference, all right? So our first example on the paper, we're going to do ST. First off, a little, actually, hang on. Before we get to that, I want to answer the question that's in the left column right there. Why did we take the absolute value? Okay, think about this. When you take the absolute value of a positive number, it doesn't actually do anything, right? The absolute value of a positive number is just that number. But the absolute value of a negative number, if you're taking that, you turn that negative number to a positive, right? Okay, so the reason we're doing that is because what the absolute value is, the absolute value of a number is the distance between that number and 0 when they're on a number line, okay? And it does not make any sense for a distance to be negative. All right, sometimes when you're adding and subtracting with negative numbers, you end up with a negative answer, right? But how is something going to be negative 3 feet away from you? That doesn't make any sense, okay? So the reason we take the absolute value of these numbers is because distance is always a positive number, okay? Distance is always a positive number. So when we look at this first example, what we're going to do, first of all, the problem is asking you to find ST. That's italicized right there, okay? What that means is this is the little M right here. That stands for measurement, okay? It's asking for the measurement of segment ST. Remember that segment does not have arrows on either side of that thing. A segment is just this chunk from S to T. Okay, not extending past it, not in either direction. It's just that chunk from S to T. All right, so when you see ST by itself with no symbol on top of it, it's talking about the length. Okay, so on your left-hand column, when it asks what is the difference between ST with nothing on top and ST with the segment on top, ST with the segment on top is referring to the object itself. ST without anything on top, like this right here, is referring to the length. All right, so that's what we're going to look for. That's the distance from S to T. Now we can find that pretty easily, which we're going to do right here. Okay, if we're trying to find ST, find that length right there. Step 1 says we got to take those two values and subtract them. All right, so we can do -4 minus 8, which gives us -12. Or we could do it the other way around. We could do 8 minus -4, which, of course, subtracting a negative, that's the same thing as adding. All right? So we can take those and make it into adding. 8 plus 4 is 12. Step 2, this is very important, make sure you're not getting a negative answer, okay? Step 2 says take the absolute value, so if you end up with a negative number up here, your final answer becomes a positive number. Okay, and that's because distance is always a positive number. When you take the absolute value of it, we get the same answer on both of them. So the distance between S and T is 12. That means the length of that segment, ST, equals 12. All right, ST equals 12. So we go on now to this next one. This time we're going to find TV. All right, this one is pretty easy. Step 1, we can do it two ways. We can go 8 minus 14, or we can go the other way and do 14 minus 8. we end up with -6 or +6, depending on which way you wanted to do it. Either way, you take the absolute value at the end, and we end up with an answer of +6. So that means TV is +6. The length between T and V, that distance, is +6. All right? The rest of them, I want you to take a second, pause the video, and do the rest of these all on your own. Okay, here's what I got for those. We got SU is 14. The distance from right here to right here, 10 minus -4 is 10 plus 4 is 14. For SV, we got 14 minus -4, we got 18. For TU, we got 10 minus 8, which was 2, or 8 minus 10. The absolute value of -2 is +2. Okay, and then UV, we got 14 minus 10 is 4. All right, make sure you ended up with all positive answers, okay? Because we're finding lengths. Lengths and distances, they are always positive numbers. You should not have a negative answer for a length. All right, this next thing right here is segment addition. Okay, postulate 1.6 is the segment addition postulate. So when you're writing that down on your notes, this is the segment addition postulate. All right, and it's really almost self-explanatory, but we're going to go ahead and point it and write it down anyway, okay? If you have 3 points, A, B, and C, and they are collinear, that goes in your notes. They're collinear, okay? That means they're all on the same line. We talked about that in the last lesson. You've got A and B and C, and B is between A and C. All right, so on your picture, put those placement. A, B, and C are collinear with B in the middle. What we can do is we can take AB, this first segment right here, plus BC, this other segment right here. When we add those two together, that is the same length as AC, the whole entire thing. All right, AB, this length, plus BC, this length, equals the whole entire length altogether. All right, so fill in those labels on the picture on your notes, and then put this equation in the blank space to the left of the picture on your notes. All right, we're going to do some examples. Number 1 says we've got a picture on our notes of a line segment of a line segment E with E and F and G all on it. All right, this one tells us that EF is equal to 28 and FG is equal to 7. So we want you to start off by labeling on your picture the values that are given to you. E to F is 28. F to G is 7. Okay, those two lengths are 28 and 7. The segment addition postulate tells us that if we are trying to find EG, remember that's what we're trying to find here. That's what the question is asking for. We know from the segment addition postulate that if we add this plus this, EF plus FG, that'll give us the whole thing all together, EG. So we're going to plug in those values. 28 plus 7, and that gives us that EG equals 35. EG equals 35. This next one, example number 2. This time is a little different. This one gives us EG, and it gives us one of the small chunks. We need to find the other small chunk. All right, so we're going to use that same picture. It's already printed on your notes. This time it tells us that the whole entire thing altogether is 40, and only one piece of it is 15. So we're trying to find what this other chunk of it is. All right, segment addition postulate tells us that one chunk, EF, plus the other chunk, FG, equals the whole entire thing. So we're going to plug in now, we're going to plug in the numbers that we have. 15 is one of the chunks. The other chunk, FG, is unknown. That's what we're looking for. And we know that the two added together is 40. So if we just do some quick subtraction, 15 on both sides, we find that FG is 25. All right, so that would be our answer to this problem. 25. I'm going to put that inside of a box right there because that's our final answer. Our last example, we're going to throw in some algebra skills in with it. All right, this one tells us that our whole entire thing altogether, EG, is 59. We need to find what the two chunks are based on this right here. All right, so our given values, all we have is that the whole thing all together is 59. That's all we know right now. But the segment addition postulate tells us that if we add these two things together, that's equal to the whole entire thing, which is 59. So we can take EF plus FG, and that is EG, the whole thing. So we've got 8x minus 14 plus 4x plus 1. We add those together, and all we're doing now is we're trying to solve this equation. All right, first we combine like terms, and we get this right here. We combine 8x and 4x, and then we combine minus 14 and plus 1. Then we're going to add 13 to both sides. We get 72 over there. 12x equals 72. And so to get x by itself, we got to divide, and that actually divides evenly. 72 over 12 turns into 6. All right, so x here is equal to 6. The question, are we finished with the problem right here? And the answer is no. Okay, you got to remember that the question is asking for what are those two pieces equal to. All right, so we have to take this x, we have to take this 6 and plug it in wherever we see an x. We have to substitute that x back in. All right, so if EF, our first chunk, is 8x minus 14, well, that's 8 times 6 minus 14. 48 minus 14 is 34. We got to do the same thing for the other chunk. FG is 4x plus 1. Well, that's 4 times 6 plus 1. That's 24 plus 1, which is 25. Y'all know what's even better than 24? 25, that's correct. So our last thing, check your work. Okay, does it make sense to have those two chunks equal to 34 and 25? Well, if we add them together, we get 59. Which is what we started with at the beginning of this thing. Okay, so that tells us that we probably ended up with some pretty good answers. All right, that's all we got for this lesson. Y'all have a good day.